Hi friends, in this video we are going to see about ABG interpretation, arterial blood gas analysis. To report or analyze an ABG, we need several values which are pH, PCO2, carbon dioxide, HCO3, bicarbonate and PO2, oxygen. The normal values are for pH it is 7.35 to 7.45. For PCO2 carbon dioxide it is 35 to 45. For HCO3 bicarbonate it is 22 to 28 and for PO2 oxygen it is 80 to 100. In this video we are using ROME method, ROME method, which means respiratory opposite and metabolic equal. It is a shortcut method, you can use it anywhere. R stands for respiratory, O for opposite and M for metabolic and E for equal. You can remember as ROME, ROME. The first step is to find whether the given value is acidosis or alkalosis. To find whether it is acidosis or alkalosis, you can take the pH value. The normal value of pH is 7.35 to 7.45. You can just check if the pH value is greater than 7.45, it is alkalosis, and if the pH value is lesser than 7.35, it is acidosis. Just check the normal value of the pH. If the value is lesser than 7.35, it is acidosis, and if the value is greater than normal, it is alkalosis. Just compare the normal value of pH alone. By this way, we can find whether the value is acidosis or alkalosis. In step 2, we can find whether the given value is respiratory or metabolic. To find out whether it is respiratory, we should compare the values of PCO2 carbon dioxide with pH. Both should be in opposite direction. One should be increased and one should be decreased. For example, if the PCO2 is increased, the pH should be decreased. Or else if PCO2 is decreased, the pH should be increased, which means opposite directions. And for metabolic, the same. We should compare HCO3 with pH, bicarbonate with pH value. Both should be in equal direction. Either both the values of HCO3 and pH should be increased, or both the values of HCO3 and pH should be decreased. Don't confuse yourself. I'll explain you with the examples also. Just remember ROME word, or respiratory opposite and metabolic equal. For respiratory, both should be in opposite direction. For metabolic, both should be in equal direction. For respiratory, we should compare CO2 with pH, and for metabolic, we should compare HCO3 with pH. Here there are 4 examples which will help you to understand more clearly about reporting an ABG. We will take the first example. In this first example, pH is 7.21, PCO2 is 52, HCO3 is 24. First, we will take the pH to rule out whether it is acidosis or alkalosis. The value is 7.21. We already know that if it is lesser than 7.35, it is acidosis. So we found out that the given value is acidosis. Now we want to know whether it is respiratory or metabolic. We will check the other values. Here the PCO2 value is 52, which is greater than the normal value of 35 to 45. Now we will compare both PCO2 and pH value. Here pH value is decreased and PCO2 value is increased, which indicates that both are in opposite direction. As per our phenomenon, ROME method, respiratory opposite. So both are in opposite direction. So we can confirm that the given value is respiratory, and we already found out that it is an acidosis. So respiratory acidosis. Still, there are 3 examples. You will be more clear after we are finishing these 3 examples. Okay. And second example, pH is 7.50, PCO2 is 27, HCO3 is 26. In the second value, first we will check whether it is acidosis or alkalosis. pH value is 7.50, which is increased, which indicates it is an alkalosis. And next we will check the other values. Second is carbon dioxide value, which is 27 only. It is lesser than the normal value of 35 to 45. Now we will compare pH and PCO2 value. pH is increased than the normal value. PCO2 is decreased than the normal value, which indicates both are in opposite direction. One is increased and one is decreased. We already found that it is an alkalosis, and now also it indicates in opposite direction, so it is respiratory alkalosis. And third one, in the third example, we will take the pH value. It is 7.19, which is lesser than the normal value. We already know that if it is lesser than normal value, then it is acidosis. Now we have found out the half part, which is the given value is acidosis. And now we will check the PCO2 value. Now PCO2 value is 38, which is absolutely normal. Nothing to do with the PCO2 value. Now we take the next step of HCO3, carbonate value, bicarbonate value. Bicarbonate value, normal value is 22 to 28. Here it is 20 only, which is decreased. So there is issue in bicarbonate value. Now we will compare both HCO3 and pH value. pH value is already decreased and HCO3 is also decreased. So if both are in same direction, equal direction, it is metabolic. We already found that the value is acidosis, and here both are decreasing, so it is metabolic acidosis. Next, the last example, pH is 7.62, PCO2 is 43 and HCO3 is 30. First we will check the pH value. pH value is 7.62, which is higher than the normal value of 7.35 to 7.45, which indicates it is an alkalosis. And now we will check the next value of PCO2. PCO2 is 43, which is normal, nothing to do with this problem. And next we move on to HCO3. HCO3 is increased, which is greater than 28 of normal value. Now we will compare both the pH and HCO3. pH is increased and HCO3 is also increased, which is both are in equal direction, which indicates it is an metabolic, and we already found out that the pH is greater, so it is alkalosis. So the answer is metabolic alkalosis. By this way we can find out the ABG report. The thing is simple. First we have to check the pH value, and next with the PCO2, compare PCO2 with pH, and next with HCO3 with pH. Simple to find with whether it is respiratory or metabolic. And next we move on to compensation. To know whether it is compensated or uncompensated or partially compensated, here there are three simple steps. Suppose if the pH value is normal value of 7.35 to 7.45, then it is compensated respiratory alkalosis or acidosis, like that. If PCO2 or HCO3, any one value is normal in the report, then it is uncompensated. If all the pH value, all the pH, PCO2 and HCO3, all values are abnormal, then the value is partially compensated. First is compensation. If the pH value is normal, then it is compensated. If any one of the value is normal, then it is uncompensated. If all values are abnormal, then the value is partially compensated. Okay, we will see examples also for this one. We will see three examples, each one example for all the three. First one, we will take pH is 7.38, which is normal, 7.35 to 7.45 normal value. The pH is 7.38, which indicates it is compensated. And one more thing I need to say you, in this case, forget about the compensation and these things. Just first we will find out whether it is acidosis or alkalosis. We will go through the steps. First thing is pH value is 7.38. In this case, there is one thing to remember. In previous cases, either the pH value will be above 7.3, above 7.45 or below 7.35. But in this case, 7.38, which is normal value. But here it is mentioned metabolic acidosis. How we will find, I'll tell you. In this case, what we are going to take, we will take the center value of 7.40. If value is lesser than 7.40, then it is acidosis. If value is greater than 7.40, it is alkalosis. By this way, we can find out whether it is acidosis or alkalosis in normal case scenarios. First, we will take this pH 7.38, which is lesser than 7.40, so it is acidosis. Now we will take the PCO2 value, which is absolutely normal, nothing to do with this case. Next, we will go to HCO3, which is lesser than the normal value, 22. So we will compare HCO3 and pH. Both are lesser, both are in same direction, equal direction, which is lesser. Respiratory opposite, metabolic equal direction. pH is also decreasing, HCO3 also decreasing. So it is metabolic acidosis. Now we have found out that it is metabolic acidosis. How can we find whether it is compensated? In previous slide, we know that if pH value is between 7.35 to 7.45, it is compensated. So the answer is compensated metabolic acidosis. In the second case, the pH value is 7.51, which is higher than the normal value, which indicates it is alkalosis. Now we will compare PCO2 with pH. PCO2 is decreased than normal value, so 35 to 45. Only 29 the PCO2 value. Here pH value is increased, PCO2 value is decreased. So opposite direction, respiratory opposite, which means respiratory alkalosis. Now we found out that it is respiratory alkalosis. And we will check whether it is compensated. No, it is not compensated because the pH value is not between 7.35 to 7.45. Here it is higher, so we will cancel compensated. Now for uncompensated, what is the scenario? Either any one of the value is normal. Here we can check pH is abnormal, PCO2 is abnormal. Yeah, here HCO3 is normal, which is 22 to 28. Here the value is 24. So it is uncompensated. So the answer is uncompensated respiratory alkalosis. And the last one. Here the pH value is 7.47, which is greater than the normal value of pH 7.35 to 7.45, which indicates it is alkalosis. Now we will check whether it is respiratory or metabolic. Here we will check. Here we are checking PCO. Compare PCO2 and pH. PCO2 is decreased, which indicates it is respiratory. If we compare pH and PCO2, pH is increased and PCO2 is decreased, which is in opposite direction, which indicates respiratory alkalosis. But see here, then we have to see about whether it is compensated or uncompensated or partially compensated. For compensation, we should check the pH, which is not normal, so we can cancel the compensated. For uncompensated, any one of the value should be normal. Here pH is abnormal, PCO2 is abnormal, and HCO3 also abnormal. So all the values are abnormal means then it is partially compensated. So the answer is partially compensated respiratory alkalosis. Here we in the third point I have mentioned, if all pH, PCO2 and HCO3 all values are abnormal, then the values are partially compensated. And that's it, friends. In case if you are having any doubts in the videos or you want to give any feedback or suggestion, please type it in the comments. I'll reply to the comments. Thank you. Please share and support.